It is time for a Network Admin's Book of WANs. Well, this is going to be more like a summary or actually a pamphlet. And let me tell you why. And this isn't, Cisco bashing or anything. Obviously, I love Cisco or I wouldn't be doing this for a living. They made some odd cuts when it came to dividing material between ICND1 and ICND2. And one of those is with the wide area networks. Because you're getting a high level view and introduced to a couple of concepts, but you're not really doing a lot of it. And the thing is, the great part is that you're in the video boot camp, which I hope you pay to get into. And the great thing is you don't have to pay to get in again. You've already got all the ICND2 videos. You've got all the videos for the entire CCNA course. So here's the thing. If you're taking the 2 exam path, then I would recommend strongly that you watch the WAN videos in the ICND2 section before taking ICND1. It's not required. We've got the WANs covered here in this 12 to 15 minute discussion because they don't exactly have a ton of it in the ICND1. But the thing is, the concepts that we talk about here, you know the deal. It's really driven home when you see it in action. Reading about it is one thing, but when you actually see the live commands and everything else and the debugs and the shows and everything that I do in my labs, it really drives everything home. And then the ICND1 WAN questions are going to be easy for you. So again, just a strong recommendation that you do that. And let's go ahead and dive into our high-level discussion here of wide area networks and a couple of terms that confused me a little bit when I got my first WAN job. And yes, we had WANs then. And I don't want them to confuse you, so we'll clear them right up. Now, here's a typical WAN connection. Doesn't this just seem innocent? Look at that. We got a nice serial connection between a couple of routers. What could go wrong here? Well, hopefully not a lot's going to go wrong here. What we're really concerned about right now is all the options we have for this connection. Some that might surprise you. And we're going to start that discussion with HDLC and PPP. These are the options we have for our point-to-point WAN links. The high data link control protocol and the point-to-point protocol. Now, a Cisco serial interface is running HDLC by default, and in this output of show interface serial 1, you can see encapsulation HDLC on the 4th line down. For reasons we're going to discuss in a moment, you'll likely want to change this default. Now, before we talk about that, let's talk about this version of HDLC that we have on Cisco routers to begin with. It's actually a version of HDLC developed by Cisco. Now, it's not Cisco proprietary, and technically it is known as CHDLC. You may never see it listed that way until you're reading, CCIE level material, because Cisco books just call it HDLC. And I understand that from their point of view, but I just want you to know if you're reading a vendor independent book for another certification exam or just reading one for fun, and you see CHDLC, I want you to know what that is. It is Cisco's version of HDLC. Now, what was their reason for doing this? Did they just have, nothing else to do? They had plenty to do, but here's the deal. The original HDLC did not offer multi-protocol support. And that wasn't going to work short or long term with Cisco routers. So what Cisco did was they added a type field to the original version, and bingo, or voila, multi-protocol support. Now HDLC has some pretty serious shortcomings, and the shortcomings really are things that PPP offers. And here they are, and this is a good reason, or several good reasons, why you would want to change from HDLC to PPP. PPP offers us authentication through the use of the password authentication protocol PAP and the challenge handshake authentication protocol CHAP. It offers support for error detection and error recovery features, and it offers multi-protocol support, which we know now that Cisco's HDLC offers, but the original HDLC did not. These are not all of PPP's advantages over HDLC, not by a long shot, but as network admins, they're the ones that are most important to us. Now, no look at WAN protocols would be complete without a look at frame relay. And the following intro is from my ICND2 material. When you hit that and you pursue your CCNA, like I said, when you watch the ICND2 videos for the WAN, you'll see all of this in action. But let's talk about how it works and what the heck a frame relay cloud is. Point-to-point networks are certainly nice. There's nothing wrong with them in the right place, but there's a real limit to the scalability. It's just not practical to build a dedicated PTP link between every single router in our network. You can imagine. And it's not cost effective, it's not practical, it's not time effective. It would be a lot easier and a lot cheaper to share a network that's already in place, and that's exactly what we do with Frame Relay. Now, a Frame Relay network is a non-broadcast multi-access network, NBMA. Sounds complicated if this is the first time you've seen this term, but it's not. Non-broadcast, it doesn't mean that broadcast cannot be sent over Frame Relay. It means that they can't be they won't be transmitted by default. Same goes for multicast. Broadcast and multicast are treated the same way by NBMA. They can be sent, but they won't be sent by default. Multi-access, of course, refers to the fact that we are sharing the network with other devices. Now, Frame Relay Cloud, 15 years ago when I got my first WAN job, where did that time go? The term cloud was not exactly popular. When you told people cloud, then they actually look up to the sky. They didn't even think about, oh, we could put things and store them on the cloud and keep our videos in the cloud and et cetera, et cetera. But Frame Relay Cloud, when I first heard that term, it's like, what is that? And you'd read certain books that were out there, and it's just like, okay, that's not helping. Well, all this is the service providers collection, or the Frame Relay providers collection of Frame Relay switches. That's what it's called. It's called the Frame Relay Cloud. And you'll often see the service provider switches represented with a cloud drawing in network diagrams. And that's not just with Frame Relay. You'll see that with several different technologies today. But yep, the Frame Relay Cloud beat them all. Now we have two different kinds of equipment in this network, two categories. We have data circuit terminating equipment, DCE, and data terminal equipment, DTE. Really want to watch this one. The frame switches and something called a CSU DSU, those belong to the Frame Relay provider. We don't configure them. Now, the CSU DSU that supplies clock rate to our router may be on our property, but it's still considered to be DCE. And by the way, if you're wondering and thinking, well, CSU, DSU, is that the same thing as a CSU? Because I've heard of that, or I know of one. They're the same thing. It's just we actually shortened it over time in conversation to CSU, but technically it is CSU/DSU. Now, that DCE has got to send a clock rate to the DTE. If the clock rate isn't there, the line protocol will go down. Now, if that's a new term for you with line protocol, we could see that on the previous screen. Serial 1 is up, line protocol is up. Easy way to remember it. The first half of this output, serial 1 is up, refers to the physical state of the interface. Line protocol is up. The second part refers to the logical state of the interface. That's the way it works. And we're going to bump into several things in later labs that can bring that line protocol down. Now, those aren't going to be, obviously, we're not going to see just two frame switches. We are going to see hundreds of them. And, of course, I didn't put hundreds of them in this drawing. But the point at which our network meets that of the service provider, got a couple names for this because it's networking. The official name is demarcation point. It's also referred to as point of presence from time to time. And I just call it demarc or demarc point. That's how most people refer to it, just as the demarc. Now, the reason I mentioned that, of course, is that you're going to have some interesting discussions with your service providers sooner or later, usually Friday afternoon when they want to go home, about which side of the demarc the error is on or the problem is on. And for some reason, they always think it's on our side. And we return that favor, I'll admit it. But you can have some interesting conversations that way, and probably will one day if you haven't already. Now, the thing is with you and I, being the network admins, we don't care about the pass through the cloud. We don't care about the cloud at all. We just want the cloud to work. We just want the Frame Cloud to work. We want our data to get from point A to point B. Now, the key here is to know that there will be multiple paths through that cloud, and data is probably going to take different paths through that cloud. It's not always going to be going across the same switches every single time from A to B. That's why we call this connection a virtual circuit. Now, we can send data over it whenever we're ready, but data is not going to necessarily take the same path through the provider switches every time. Now, that is your Frame Relay teaser. We're going to get a lot more into the nuts and bolts of Frame and ICND2. And like I said, you've got access to the videos, so make sure to head over there and watch them. We're going to talk very briefly here about running Ethernet over a WAN and talk about something that even 10 years ago, most of us would not ever have considered possible. It's like, well, how are you going to do that? How are you going to run Ethernet over a WAN? Well, it was designed for a LAN. And of course, when we had, fast Ethernet, I was like, hey, it's never getting any better than this. Well, it's gotten better than this, and it's actually gotten to the point where we have EWANs, Ethernet over a wide area network. Basically, very basically, it's really set up like frame relay. We have our connection to the service provider's devices, and whatever happens in the cloud is the business of the service provider. And this is another time when you'll see the term point of presence. That's the point of connection to the service provider in an EWAN. Pardon me. Now, in Cisco LAN, we use Ethernet over multi-protocol label switching, EOMPLS for Ethernet over WANs. That's one way we do it. And we're not even sticking our toe in that water. There's no way. It's a pretty darn complex topic, and that's something we can save for later. It's not something we're going to get into right now, but it's just good to know right now that Ethernet is becoming a more and more popular WAN option. Now, talking about the cables or a cable, we have a section here we talk about, the crossover cable and the rollover cable and the straight through cable. But I want to talk about the cable that makes our WAN possible, and it's our leased line. That's our physical connection to the service provider. It's really that simple. What's not as simple is keeping up with the zillion names we've given the leased line over the years. When I would hear different engineers use these different terms when I started WAN, I was like, how many lines we got around here? They were all talking about the same thing. Serial lines, sometimes I call it a serial link. Might call it a T1 or a T1 line. Might call it a PTP link or a PTP line. More about those in your ICND2 studies, but again, these are all referring to the same thing. Serial line, usually T1. Sometimes people refer to a T1 line that isn't even running at T1 speed. It's just their generic term for that leased line. Now let's talk about home WAN access. We're going to spend a little bit of time going back to the old days. It was once limited to a connection that by most of today's standards would just be horrendous. You connected to the internet service provider. I still have my baseballs from winning my 1993 Prodigy Fantasy Baseball League. And hey, it was dial-up and the font wasn't much to look at, but we were just, darn glad to have it. Well, for many of us, the argument about internet access versus using the phone, that's in the past. But not for everybody. Analog modems, dial-up modems are still out there, and we can't use the phone and access the internet at the same time with those. That was a huge step forward for us when we started getting connections at houses, where you didn't have to tie up the phone line to get on the internet. Because most of today's home users utilize digital subscription lines, DSL, to connect to the internet with a specialized piece of equipment on each end of the connection, and it was party time. No more looking around. Do we have an AOL? What's the latest AOL version? Does anybody have a disk? And you could access the internet when someone else used the phone. So the home user just connects via a DSL modem, and in turn it communicates with the DSLAM, the DSL Access Multiplexer. Sounds kind of violent, DSLAM. Now, we're going to see multiplexing pop up later in the course, so I want to define that term now. And this illustration is courtesy of Wikipedia, user the Anom, or Anomi, however you want to pronounce that. And I love this drawing because you see the multiplexing and the demultiplexing. Because multiplexing, it's just the process of sending multiple data streams simultaneously over a single channel. And once the data has crossed the channel, it is demultiplexed, if you will. Now, in the case of DSL, we're using the phone line, so we're multiplexing computer data and voice data. And this allows us to access the internet, again, while someone uses the phone. And for many of you've never known otherwise, perhaps, and it's just like, big deal. Well, it was a big deal at the time. A couple of DSL types here. I'm not going to go through every single DSL flavor out there, but there are two in particular, and you might be reading this over one right now. We have asymmetric DSL. This is the DSL type that delivers greater speed in the downstream direction than upstream. And that's how most people actually want it. If they have the choice of 50-50, or you ask an end user, would you rather be able to download faster and then upload, or, slower, that's fine with them. But for the 50-50 split, you have symmetric DSL, SDSL, where the upload and download streams flow at the same rate. Not all home internet access is through the telephone line. Many homes connect through their cable connection. And, I've had that connection myself. And when the net connection would drop, the first thing you did in your troubleshooting after checking the cables was to see if the cable TV was still working. And if it wasn't, you said, okay, it's a provider issue. And there just isn't a whole lot we can do about it. So let's see. This actually concludes our quick look at our WAN technologies. Came in right at 15 minutes, which is what I thought. And our DSL variations, we will hit frame, PPP, and HDLC harder in your ICND2 studies. And again, you know the drill. If you're taking ICND1, I recommend you watch the ICND2 WAN videos as well so you can see a lot more labs. And if you want to go way beyond the scope of the exam regarding DSL, check out Wikipedia because they've got more there than you might ever want to know about it. Thanks for watching this video. Let's head to the next section.